This video is on adding and subtracting rational expressions. And we're actually going to go through this in a couple videos. This first part being, I'll talk about the steps involved and then how to actually add or subtract. In this first video, all the expressions we'll talk about already will have a common denominator. In the next video, in the next section, we'll talk about what if they didn't have a common denominator. But I'll write the steps first, so this will cover the steps for both videos. So for our steps, all right, when I say adding or subtracting rational expressions, remember rational expressions are fractions. They have polynomial numerators and denominators. So the first thing you want to do is when you add or subtract fractions, is the first thing you always need is a least common denominator, an LCD. So first thing you want to do is find the LCD for all fractions that are being added or subtracted. Alright, so first thing you want to do is find the LCD. After that, typically when you're adding or subtracting fractions, you find the LCD and then you want to rewrite each fraction. So you want to rewrite each fraction in an equivalent form. Using the LCD as the new denominator. So you find an LCD and you rewrite each fraction in an equivalent form using the LCD as the new denominator. So you don't just change the denominator to whatever the LCD is, you are rewriting it in an equivalent form, which means you'll have to change the numerator as well by multiplication. Step 3, and then you're going to add or subtract, depending on the operation that you see. Add or subtract through the numerator, and you keep, alright, so keeping the denominator as the LCD. So you add or subtract straight through the numerator, through the top, and you want to keep the denominator the same, right? That's what's allowing us to add and subtract, is that the numerator, right, or the denominator is going to be the LCD, is going to be the same. And then lastly, we want to simplify if possible. Simplifying for a rational expression, remember, means factor the numerator completely, factor the denominator completely, and then cancel out any factors they have in common. So you may want to pause the video here to write down the steps if you weren't writing as quickly as I was, and then we'll start with some examples. So for the first example here, if we say, I'll write add as the directions, but the directions could be perform the indicated operation, and we'll have 3 over x minus 7 plus x minus 9 over x minus 7. So a fairly straightforward one to start. And like I mentioned in this video, typically because our textbook does this, the examples I'll show you already will have a common denominator. So when I go to add these, first off, the operation's addition, because you see the plus sign. All right, so you should know that if it just said perform the indicated operation, addition's the operation. We want to add these fractions together. The first thing you need is a common denominator. In this case, the denominators are the same, x minus 7, x minus 7. So we have the common denominator, so we don't have to rewrite each fraction because they already have the denominator. So what we have to do is really we're going to skip to step 3, which is add or subtract through the top, all right, and keep the denominator the same. So add or subtract through the numerator, we'd end up with 3 plus x minus 9 all over, this is x minus 7. And then we'll combine like terms here. Combining like terms, and I'll write it in descending order. We'll have x doesn't combine with anything, so we'll just keep x. 3 minus 9 is a negative 6. We have x minus 6. Make sure you keep the sign as the operation. In the denominator, I have x minus 7. And then now we have to ask, does this simplify any further? Well, in this case, no, it won't, because x minus 6 and x minus 7 are different factors. So we'll keep it the same. If it was something you could factor down, you would factor down to simplify. But if you have a common denominator already, you add or subtract through the numerator, keep the denominator the same, and then combine like terms in the numerator and keep the denominator the same. If anything factors and cancels here, then you would factor and cancel. So that's a fairly straightforward example. Let's take a look at another one. Alright, for this next one, let's take a look at this. So if I said to add x squared minus 8x minus 1 over x plus 4 times x minus 6 plus 3x minus 5 over x plus 4 times x minus 6. Now remember, this could say perform the indicated operation. You know the operation's addition because of the plus sign in between these two rational expressions. And the first thing you would need is a common denominator. In this case, we do have one. Our denominators are the same, so you don't have to bother finding it. Later on, you'll notice that this being in factored form actually helps us. Don't FOIL through this, so you distribute through and then come up with an expression that is a polynomial, because then you'd have to undo that later on maybe. So we have a common denominator for both of the fractions. So now remember how you add. You add straight through the numerator. So we would have x squared minus 8x minus 1 plus, now because this is addition, I'm adding the 3x minus 5. It's really a positive 1 times each of these, but they'll stay the same. So it'll be plus 3x minus 5, just written like that, all over x plus 4 times x minus 6. If this was subtraction, though, the minus sign would belong to every term in the numerator, and you have to distribute the negative through, so it's something to watch out for. So now we've written this as a single fraction over our common denominator, and now we want to add or subtract straight through the numerator. So we have x squared. There are no other x squared, so combining like terms here, x squared will stay the same. Negative 8x plus 3x is a negative 5x. And then we got negative 1 minus 5, which makes that a negative 6. So I have x squared minus 5x minus 6 over, don't lose the denominator, x plus 4 times x minus 6. Now once you're here, you've combined like terms in the numerator. The next thing you should do is try to simplify this as much as possible. Remember, to simplify a rational expression, you want to factor the numerator and denominator completely. In this case, the denominator is already factored. If it wasn't, you should factor it. In the numerator, to factor this, you factor how you normally would, looking for a greatest common factor. In this case, we don't see one. We have 3 terms, so we look in the front of that first term. The leading coefficient here is just a positive 1. In other words, you don't see a number there. So that tells me I can make 2 sets of parentheses, and if this is going to factor, right, we have x times x, meaning things that multiply to a negative 6 and also add to a negative 5. And the numbers that do that are negative 6 and a positive 1. Be careful there. Don't use 2 and 3 because you won't be able to get to the negative 5, or you won't be able to get the negative 6 as multiplication. So negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So that's how that factors. Down here I still have x plus 4 times x minus 6. And now, does anything cancel here? Well, yes, the x minus 6's, right, common factors of both numerator and denominator will cancel out. So you're left with x plus 1. You don't need parentheses around it, over x plus 4. You don't need parentheses because there's nothing being multiplied through these. That doesn't simplify any further, remember, because these factors are not identical. So you can't cancel the x's because that x is married to that 1 by that plus sign. This x is married to that 4 by that plus sign. So you can't cancel any of that out. So let's take a look at an example here involving subtraction. Alright, so if I said to, for example, subtract, and we'll have 3x squared plus 15x over x to the third power plus 8x squared minus 20x minus, we'll have 2x squared plus 5x in the numerator for my second fraction over x to the third plus 8x squared minus 20x. So when we look at this, you know, the first thing you should think to yourself is I'm subtracting, right? That's what the minus sign in between here says. If you didn't have the minus sign, you know, you wouldn't know what the operation is, right? The operation is subtraction, so even if it didn't say subtract, if it said perform the indicated operation, the minus sign tells you it's subtraction. And then you want to see, do you have a common denominator? Now in this case, the denominators, yeah, they are the same. So since we have a common denominator, we can, you know, add or subtract through the numerator and then keep the denominator as that same common denominator. So I'll write it out with the denominator already. So we have x to the third plus 8x squared minus 20x. That'll be the denominator for the whole fraction once we subtract. In the numerator, we'll have 3x squared plus 15x. Now, if you remember, I mentioned this in the last example. This is minus this entire thing, so it's minus the 2x squared plus 5x. You need those parentheses because the minus sign belongs to all terms in that numerator. So to simplify this, we distribute this negative 1 through, right? So this negative sign is really like a negative 1 in front, and you distribute it through. So we end up with 3x squared plus 15x. And then this is like a negative 1 times a 2x squared, so it would be negative 2x squared. So it's like a negative 1 times a positive 5x, which makes this negative 5x. If you want to write the 1 in there with the negative, you can, but you don't necessarily need to. The denominator is going to stay x to the third plus 8x squared minus 20x. So once you have this, you know, we're going to continue in simplifying. So combining like terms in the numerator, 3x squared minus 2x squared is just x squared. 15x minus 5x will be a plus 10x. And this is over my common denominator, which was x to the third plus 8x squared minus 20x. So once you've combined like terms, right, the next thing you want to do is try to simplify this. To simplify a rational expression, you want to factor everything completely in the numerator and denominator. So factoring completely here, x squared plus 10x, factoring that, the GCF that we have is x, don't forget to factor that out, and then we're left with x plus 10 inside the parentheses. For the denominator, x cubed plus 8x squared minus 20x. Well, this has a GCF of x as well, times what's left over here would be x squared plus 8x, all the powers of x are getting reduced by 1, minus 20. And now remember, I wanted to factor completely. In the numerator, x times the x plus 10 doesn't factor any further. Here, the x squared plus 8x minus 20, well, that will factor. So here's my numerator, x in front, remember, stays in front. X squared plus 8x minus 20. We have three terms. I don't see a value in front of the x squared, so two sets of parentheses, x in the front of each of them to get the x squared, multiplies to a negative 20 and adds to a positive 8. So you're looking for factors of negative 20 that'll add to a positive 8. And the factors that do that are x plus 10 and then minus 2. Right? 10 times negative 2 is negative 20. 10 minus 2 will give us the positive 8. And now we're ready to cancel. If I cancel in here, keep in mind what you're canceling out. You know, common factors both the numerator and denominator. So if nothing canceled, then you'd leave it. But here I see x plus 10 and x plus 10. Those will both cancel with each other. Here, x and x also cancel. Now, if you notice that in the first part here, you could have canceled these x's right here. I'm doing it at the end just to show you I factored completely. So it looks like my entire numerator canceled. So what's up there? Don't forget, there's a 1 up there when you cancel everything. Don't just leave it off because you say the answer is x minus 2. The answer is really 1 over and then x minus 2 in the denominator. Make sure you keep that 1 there when there's a 1 in the numerator. Something to point out, when you're adding or subtracting, right, when you're looking at this at the very beginning, if you didn't have a common denominator, you'd have to find that first. Typically, to find that first, what you would do is you'd have to factor the denominators at the very beginning to see what factors were made up to find the LCD. And we'll talk about that in a little bit. Let's take a look at just one more here. If I had this example where I have to subtract. And we'll say we've got 4x plus 1 over x squared minus 5x minus 24 minus 3x minus 2 over x squared minus 5x minus 24. So you might want to pause the video here and try it for yourself. You know, it's sometimes helpful to, practice this first and then watch the solution after if you feel like you have a grasp of the concept. So, taking a look at this, first off, to subtract these, I know it's subtraction because the minus sign in between the two rational expressions. The first thing I need is an LCD, a least common denominator. In this case, we already have the common denominator, so we can subtract these right away. So to subtract these, remember the denominator will stay the same, the x squared minus 5x minus 24. The numerator, we have 4x plus 1. Remember this minus sign has to get distributed through, so it's minus in parentheses the 3x minus 2. And then we want to distribute this negative 1 through. Now if you can do that on your own, visually that's fine, but don't miss it. Sometimes people don't even recognize that they just put the negative on the 3x, not with the negative 2. And it's important because we have 4x plus 1 here, distributing the negative. Negative times a positive 3x makes that a negative 3x. A negative times a negative here makes us a positive 2 over the denominator, which I'll keep as x squared minus 5x minus 24. Combining like terms, this will give us 4x minus 3x, which is just going to be x, and then positive 1 plus 2 will be plus 3 over the denominator, which is x squared minus 5x minus 24. And now don't stop here. Sometimes people stop here. They forget to finish the problem. Remember, the last thing you should do is try to simplify. If you have to simplify, you have to factor both the numerator and denominator completely for a rational expression. So we have x plus 3. That can't be factored any further. Over in the denominator, there is no greatest common factor. You have 3 terms, and you don't see a value in front of the x squared, meaning that the coefficient's 1. So you can write this as x times x. We want numbers that multiply to negative 24 and also add to negative 5. And numbers that do that are a negative 8, right, and a positive 3, right? Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. And now, does any of this cancel? Well, the x plus 3 factor will cancel x plus 3 here. And then again, remember, when you cancel that numerator completely, there's a 1 there. So it's 1 over x minus 8. And that's it. Don't just write x minus 8. You need that 1 from the numerator. So far we've talked about, adding or subtracting by trying to find, a common denominator, but all the denominators so far have been common denominators. So when you add or subtract fractions, you always need a common denominator. Here, all these examples that we just did had them already. So in the next part of this, we're going to talk about how you would find a common denominator.